Today we are going to talk about topic in sewage treatment plants in India. I'm always faced with this question: what is the MLSS that you maintain in your plant? And for me, this is the most uninterested question to face, because MLSS does not treat the water. It is only an indicator the water is treatable. Let's try to understand this much deeper in the coming slides. The topic we're going to discuss is STPs fail when operated with MLSS as per design. In almost every sewage treatment plant, we hear this: MLSS is maintained as per design, 3,500 milligrams per liter. Perfect. But here is the uncomfortable question: is your inlet still at the design condition? If the incoming load has changed, but the biomass is kept fixed, you're not operating a treatment plant. You're stressing the biology in the ecosystem. Today, let's understand why this thinking causes failure. First, let's understand what is MLSS. MLSS simply means mixed liquor suspended solid. It is a total weight of solid in the aeration tank. It includes living bacteria, dead bacteria, inert particles, everything else that is mixed together. This is called MLSS. MLSS tells us how heavy the sludge is. It does not give any clue on the healthy biology in the system. This is important to understand. Let's now understand how the bacteria in the system is living. Bacteria do not survive in numbers. They survive on food. That food is organic matter, measured as BOD, COD, and other nutrients. But even the COD has layers. There is part of the COD that is consumable. There is part of the COD that is not immediately usable unless it's converted to reactive portion. This is the food for the microbes. If the COD drops, the growth of microbes drop, the activity in the sewage treatment plant drop, the stability of the plant operation drops. The biology, which is made of the microbes, respond to food, not our design values. Let's understand a bit of design conditions. At the design stage, we assume 100 cubic meter per day as the incoming load, 500 milligrams per liter as the COD. That equals to 50 kilograms of food per day. Everything, tank volume, aeration, MLSS, is calculated around this 50 kilograms per day requirement. But remember, this is only an assumption. But do we know what happens in reality? Now, let's understand this. In actual, the flow is not the same. It is reduced. Reactive COD is lesser. Instead of 50 kilograms per day, you may reserve only a few kilograms of COD. That is 85% less drop in food, assuming that only 15% of the assumed load is incoming. But what about MLSS? Are we still maintaining at the design levels? If yes, this is where the imbalance or the problem begins. Let's understand with an example. Imagine a kitchen that's built for 500 people, but only 70 people show up daily. If we keep the same number of cooks, 500 people, that's the point of chaos, which is guaranteed. There may be staff that are idling, confused, without knowing what to do. They may even disrupt operation by disturbing people that are working for the 70 people. This is probably what's happening inside your aeration tank. Too many organisms, too many microbes, but too little food. The competition is high, idling staff are more, and everyone does what they like without an order. This is where we have to understand what insufficient substrate of food causes. Bacteria at this stage enters into a mode of starvation. They begin what is known as endogenous respiration, which means they're eating themselves. They start to eat their own stored energy, or the mighty bacteria is eating the weaker ones. There is complete destabilization of sludge. There's more dead sludge than useful activated sludge. Finally, what appears to be a good-looking MLSS is not resulting in good treatment. Let's understand why treatment suffers. Because MLSS is just a number of mass concentration, it does not show how much is the active biomass, which is microbes that are in active state to consume the food that is available. Because there is less food available, the system is stressed. Let's again reiterate. MLSS is just a number, whereas microbial activity in the biology is a behavior in an ecosystem. If we control only number without understanding behavior, failure in a sewage treatment plant is unavoidable. Now, let's try to ask some right questions. Let's try asking, what is today's flow? What is the level of activated sludge? Is it looking healthy? If the water is treated, then we don't have to worry about anything. This is more or less leading us to have an intelligently operated sewage treatment plant. This I would call biological thinking. Maintaining higher MLSS does not solve the problem. Maintaining it lower does not solve the problem either. Only aligning the biomass to what is real load conditions is going to make the plant work. Sewage treatment plant is not a machine. As I've told you earlier, it is a living ecosystem, a real living one. It needs understanding. It doesn't depend on operating. Thank you.